Good morning, everybody. I'm another programming session here with my program. I'm focusing on organization of the file. I'm working on the very first file because I got to thinking about it last night, after relaxing for a while, and I got to thinking about how things were organized. And so this was originally, let me scroll down, was like way down here, right? And my point is, so you got chain life cycle state, all these C's together, which is great, but then you have error severity. That's not alphabetical. So what I'm doing today is organizing it alphabetically. That's what this recording will be today. A little bit of my session. It won't be the whole day because that'll be a 10-hour video because I'm going to be doing this all day. But this is going to be just a short little what I have to deal with to make this work, right? Right now, though, it doesn't necessarily matter if it's organized alphabetically. I'm just doing that because it just makes more sense to me to do it that way. And I'll be able to show you some of the code. So this very first enum is called access level, which has 7. And I'm just going to go through one enumeration like this to show you what you can do with this enum. So it's got none, read only, read write, export only, ML train only, admin, restricted, and custom. And that's just the access. It's like permissions, if you will. So with access level, we have section 0.1, validation and comparison operators for access level. And a comparison operator is basically if you have, let's say you have 2 access levels. One is none and one is custom. Well, I think we all know what a comparison does. Is it equal to the other? Is it greater than, less than, etc.? So, but before we do that, I have this function here. It's a validation function, and it's is valid. And basically, you take, let's say we do this. Temp level equals and then we do another access level. Oh, you know what? I mean that would work. That would be an invalid value. 0, -1 does not exist in that. But we're gonna do something different. Okay, so we have 2 access levels here. Of course, I'm not going to keep this in here because I'm just demonstrating how this access level can be used. So we've got 2 access levels. One is set to none, one is set to custom. And let's see. So let's go down here because these are here. I have to have them available. So let's create a function, compare access. Let's create a function called compare access. Let's see. Is equal wait a minute. No, we won't do access level. We will do bool equals, but this isn't right. So we gotta do, I mean, that would be true. Um, okay. And to show you that code, so like I said, this, okay, so is valid. There's actually two of them. We're going to open up the functions we're using. Okay. So I just got to remember, okay, this is where I use AI too much, and I'm trying to do this without AI. Okay? I'm trying to do this without AI because that's how you learn, that's how you develop your skills. But okay, so we've got two Boolean values. We want to compare them. I don't want it to take me all day. Let's see. I know what I can do here. Because it's not going to work with the current project. Because there are so many errors. So what I'm going to do, hold on. We're going to open up another Visual Studio instance. So because I want to show you that it actually works. Create a new project. Blank. Oh, wait, you know what? No. Access level. We'll call it access level. Okay, so this is actually great. This isn't just my project. If you want to know how a programmer actually does the programming, here we'll show you. So, let's actually move it to the desktop. Makes it easier to work with. So many folders. We'll create a new folder. We'll call it access. Select folder. Okay. And he'll go ahead and hit next. Whoa. Oh, well, crap. This is not what I wanted. Nope, this is definitely wrong. This is definitely wrong. New project. I'll have to delete that. Empty. Let's just do empty. Empty project. Next. That's what we should do. I'm going to call it accesses because we already have an access level. Okay, so this is a blank project. There is absolutely nothing in it. I'm going to have to do some work, actually. Let's see. We'll go to properties. This is the first thing we're going to set up. Okay, good. That's set to C++ 20. Oh, wait a minute. New file. You know what? Hold on. I'm going to pause real quick. I picked the wrong one. I am sorry. We'll just call it Council App 1. Yeah, we don't care about getting started. Okay. First off, Linux. Linux. God, oh my god, oh my god. See? I can't even show you anything. Okay, that's all wrong too. Okay, sorry, I had to get my head together. So I have to create this whole project from scratch. Let's see. Um, we're not going to do any additional include files. Okay, so what we need to do now to test this access level to show you what I mean by this access level, because obviously my whole program is failing, so I only need one file. I need project 1, and then I need, here we are, copy. All right, beautiful. Now it's in the same directory, so I can pull this back up. And, ooh, you know what? I know what's missing here. I know what's missing. There's another file missing that will be important. Okay, now I can begin. Okay, so we're going to open up 2 files. Okay. 27,000 lines. Okay, so now that we're back up, we're going to go ahead and move core ML enumerations to the edge and this O1C standard, because I want to show you that too. Okay, so this is a blank file, and a lot of the files that I've been showing you in the past have had lines and lines and lines and lines of code, and that's because I wanted to show you the size of it. Today, I'm actually going to actively program, right? I'm going to show you how access level is used and how it can be used. And I may be using Copilot to help me do this because I can't remember how to compare. That's not good. I should know how to do that. So anyway, I'm gonna explain as I go. So we got this blank file and we've got 2 header files, right? A header file is basically just things that you need for the program, okay? And in this O1C standard, this file is kind of like a core file that everything uses, and that's because it's got a bunch of includes, right? And these are the C++ standard library headers. So algorithm, array, bitset, CAssert, CTime, CStandardLib, CCType, chrono. Remember chrono from yet the other video? Chrono is timestamps. Compare, concepts, map, memory, mutex, new. I mean, there's a lot here. Vector, which allows you to build containers. I'll get into that in another video. Today, I'm just kind of demonstrating why I have this file. Because can you imagine if I need, like, all of these are different things that I use as a programmer in the programming language. So can you imagine if every single header file, I had to type all of this? Instead, I've got a header file listing every include that I need. So all I have to do is come up to the top and go include. And because this is in a subfolder, I have to use this period / O1C standard. And now it's available in this header. Now, if, let's see, we got to do includes here. We're going to definitely need O1C standard. And we're going to need the O1 core ML enumerations. Okay, we are set for the most part. There's one additional thing that I would normally do in a bigger project. I'd come over here to project, make sure that we are using C++20. We are. Okay. And then second thing that I would check in a bigger project is look at these additional include directories. This is where additional header files are found. Since this is all contained in one folder, I don't have to really add anything here. I'm going to hit OK. Okay, so now we have our included files in. So the next thing we have to do is we have to make a main function. Okay. This is if I were to run this right now, we're going to go ahead and save this file. Clean the solution and try to run it. Oh, I know what's going on here. It's because the file got moved. Okay, that's simple. Save. Yes, I want to replace. Okay. Now this is going to run, and this is all it's going to do is return 0 because there's nothing in there. First successful attempt at programming. Starting from scratch. Okay, so okay. Sorry about that little pause there. I have animals in the house, and a cat was wanting to get in my lap. I had to pause for a second. Sorry about that. Anyway, so now, like I was talking about, this core enumeration file, this access level, and this is valid. So let's test this is valid, right? Let's run a program. Let's build something. So we'll call it testing access. That's what we're going to call this. And then we're going to go access level. And we're going to, let's see, what do we want to call this? And I can call it anything I want, right? It doesn't matter what I call it. Access 1 equals now what is going on here? All right, access level is undefined. How is access level undefined? Let's see what AI has to see. Uh-oh. What? Oh. Oh, okay. I see. Oh, okay. I forgot to do that. Oops. Usually you don't want to do like using an entire like namespace. But in this case, ta-da! Oh, there's no member read. Let's take a look at access level again. It's read only, not read. Okay, so let's do that. Let's do read only. All right. So see, this is how you can use that access level now. But what does this do, right? So, is equal. Wait a minute. This is where hold on. Okay. Okay. Ah. All right. Let's find out if these are two equals or not, or if they're not equal. Okay. So we'll save the main file. Okay. Oh, I know what's going on here. Forgot to do something. Forgot to do something. Kind of helps if you add the function to the main function. It won't run otherwise. Save the main. Save main. Yes. Build, clean solution, and rerun it. Now it should say that they're not equal. See, yeah. Are they equal? False. Are they not equal? True. So that's exactly what it says. That access 1 is not equal to access 2. And access 1, like, it's false. Is it equal? It's false. So that confirms that nope, those two access levels are not equal. And it's verified by output. True or false, simple, really. And then we can also, so like, let's see. Oh, I want to check that is valid because there's that validation function, right? So access, you know what? I don't even need to build a new access level. You know what? Yeah, I do, to hold the value. Why did I do that? So see, well, and you may be wondering, well, why does the access, so why does that set that to 0, right? Well, that's because hang on. Huh. Because I'm looking at my code and there's no if statement. Like typically, because well, I mean, like let me show you an example. So in the add checked, this is a lot of code. uh, hold on. Yeah, see, but that's custom. I am gonna ask. I'm curious. So I'm curious. Oh, I know why. Okay, never mind. I'm not going to ask this question because I'm looking at this code and seeing the answer right here. This is where it's at. Okay. And so what this line does here, right? Now I know why we get 0. Okay. Now I understand why it prints 0 there on access 3. Um, okay. So I was about to make a fool of myself in front of y'all, and it happens. It does. Okay. So what this statement here states, which is access 3, it's calling upon the is valid function that only takes one parameter, this very first one, which this function, and I'll explain it, has a parameter. So a function is this. This is what we call a function in programming. And functions don't necessarily have to have parameters. It's called a parameter. And it goes in between the parentheses at the end of the function. So in this particular function, what this allows me to do is it allows me to take an access level, throw it into this function, and then it will take it and do whatever it's got to do. That's what a parameter does. So now that we got that out of the way, so in order for an access level to be valid, it has to be between 0 and 7. 0 being the lowest and 7 being the highest, right? Well, in main.cpp, in this very line, we have access level, access 3 equals is valid with the necessary access invalid, which is this access level, with a -1, which is invalid. It's not in the scope of the enumeration. So if it is with the, and then it has a question mark, so it's asking if it's valid, if this is valid. If it's not, then make it access level none, which, if you go back to core ML enumerations, is 0. So that makes sense that it would print 0 because the original enumeration that I tried to use was not valid. So it put something in there that was valid, which would be none because there's no access level now, if that makes any sense. Um, let's see, what else can I do with this? I told when I mentioned vector, I didn't really go into detail on what that is. So a vector is quite interesting, actually. So we'll go ahead and vector find. We can do something like that. And then you'd be like, well, okay, that's cool. You're storing a bunch of access levels. What does that do? Well, we could also print them out. That's wrong. There we go. There we go. That's better. All right. So let's go ahead and clean the solution and try it again. And see, it prints them out. Access levels in vector. Index 0, access level 0. Index 1, access level 1. So on and so forth. And this is just many of the things that I can do with these enumerations. They, like I said, they're just states. So now that at least we know it works, right? With all those errors I have in my program, at least I know that access level works. I know that I can tell whether or not it is equal or not. And you know what? I'm kind of curious. Let's test that is equal. Let's change this to read only. Now they are definitely equal. Okay, so let's go ahead and clean the solution and rerun it. And now it should say is equal. And they're not equal. There, see? Yeah, and it works just like it should. The equal. At least I know that the equality operator works. Okay, enough of this programming, like individual programming. Like this is kind of like a simple like, hey, this is what you can do. And before I go any further, I want to demonstrate something kind of cool that I learned in programming with this for loop. So now I didn't really explain this for loop. I just kind of said, hey, yep, it prints everything out. But what this is doing is this is saying for every integer. So a for loop basically allows you to do something a certain amount of times in a vector or in whatever container you're using. And so you have the for statement, the initial variable, which is I. You set that to 0 because you want to start at the very beginning. And then this statement is important. This basically, so access levels dot size. Dot size is a member function from the standard library for vector, which gives you the maximum amount of elements in that vector. And you have to use I is less than access levels dot size to make sure that when you're going through these loops, you don't go outside the vector. And that's what that line does there. This prevents this I is less than access levels dot size, basically prevents you from going outside the vector. And this plus plus I is an increment operator. It allows you to go forward in the vector. And then of course we're just printing out index, access level, and then this is static cast because access level is not an integer, but you can it is an integer, but you can use the static cast, which forces access level, right? Access level to become a number. It forces it. So a fun little cool little trick. You want to see a bunch of ones printing really fast? Watch this. Now remember, a for loop has to have conditions. Meaning, if you do something like this, actually, you know what? We're going to put the number 1 in there. I mean, I can use that, but we'll space it. Okay, I wonder what this little line of code's going to do. Let's find out. An episode. Oh, it didn't even let me do it. Aw, you make me sad. I want to do it. It's an infinite loop, that's why. Um, hmm. Obviously, it's not going to let me do it, so I'll do something like this. Now, this is kind of cool. Check this out. This is another way to use a for loop. One, 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 one. Or, if you wanted to, you could. Let's do 20 numbers. Um, I don't want to. No, I don't want to do that. Um, you know what? No, this actually needs to come out. Um, we're gonna start this with one. I'm gonna show you something cool. Okay, so what I'm doing here is I'm trying to print out a bunch of numbers, like multiples of 2. So, actually, we need it starting with 2. We're going to start with 2. And we're going to do 20 numbers at 20. And so if you wanted to do a bunch of calculations really quick, um, this is a quick way to do it. Let's try this. There you go. Seed number 4 through seed number 2009, 2 million. Yeah. And that's just simple stuff you can do with programming. But without further ado, we're going to close that out because that's not what I'm actually working on. This is what I'm working on. So now I'm going to explain the code that got to those results, right? Okay. So start, like I said, access level. Let's go ahead and get rid of all that. That's no good anymore. Okay. So in the operator equals, it's got left-hand side and right-hand side. In the very first if statement, it's taking this function, it's throwing in these two access levels, and it's determining if it's valid. If it's not valid, it returns false. If it is valid, then it determines whether or not it's equal or not. If it turns out that it's not valid, it returns false. Same with not equals. Get rid of this too. I'm gonna close these out. And of course, it wouldn't be complete without greater than or equal, less than, and greater than. So this is the actual code for it. Less than or equal, same difference. Greater than or equal, same difference. And then we got the spaceship operator. The spaceship operator is C++20. It basically combines all those operators into one. I have it just for Dexter. I have all of them just because it's good to have them all. And then we get into more interesting operators. So like the stream operators. And a stream operator is something that allows you to print it out. And I'll demonstrate that as well. Oh, I should have demonstrated that as well. I'll show you the function though. Okay. In the very first if statement, we're making sure that whatever valid or whatever level we're printing out is valid, and it is in fact valid. If it's not, it prints out invalid and then the level name or level number. After that, after it's been verified, then it goes through a switch statement, which a switch statement allows you to choose between a bunch of options. And using cases, as you notice here, case and return. And the return is simply just going to return text, none, read only. And that's literally all it does, is just prints it out on the screen. That's all that does. And then we go on to the input operator. This is unique, because there's a lot of if statements. But in this one, this is input coming into. So let's say you establish an access level, but it's not set up yet. Well, you can use the input operator now that I have this established. And in this logic, it's got a standard string input, and then an IS, which is an input operator, this IS stream, and then it puts it into the input. If the stream is already in an error state, return the input. We were going to convert it to lowercase for case insensitive comparisons, and then it checks. And then if all of this fails, then in the else block, and these are if statements. The if else, it's like if this happens, then do this kind of thing. And the very end of this block, it has a try block, which that's exceptions. That allows you to catch errors as the program runs. And then after it's parsed, the input that you've put into this input operator, it does one final validation before accepting the data. And then that's this statement here. Return IS. That is the end of the function. That is what puts that data into the variable. And this is just another one. It does numerics. See, it's real simple. Boop, boop, boop. Got some bitwise operators. Now, so you can add them together. Absolutely. You can add an offset to an access level. So let's take a look at that. Oh my. Another one. And in this one, this function is going to make sure that if you're adding two access levels together, they don't go above custom or 7. So that means if you have an access level that is restricted, you can't add anything to it other than 1. You can add 1 to it, but that's it. Or 0, because 6 plus 0 is 6. 6 plus 1 is 7. But if you try to add a read-write into a restricted, first off, that makes no sense. And secondly, it goes out of bounds, which is why I set it up like that, because it just goes, you don't want 8. There's no 8 down there. So that's the first thing it's going to do. It's going to make sure So, and that's what I'm going to show you. So we have a minimum value, that's none. That's none. We have a maximum value, max val. That's custom. That's custom. And every single enum in this file is the same way. So, and then we have our level value, which is this guy right here, this parameter here, up here on this function. So, first we want to make sure that there's basic validation. And if it fails, we set it to custom. After that, it goes on to this. If the sign is 1, which means we're wanting to add, for addition, we want to make sure that we wanted to make sure to check if the offset exceeds the distance to max. So we establish a variable here called const, which means it can't be changed. Integer max offset equals max val, which is custom, minus level val, which is whatever value you have. So what that's doing is that's taking custom and it's subtracting custom from your level. And then that's basically going to be the maximum offset that you can use. So the maximum offset for 6 is 1. Because 6, hold on. The maximum value is 7. What is 7 minus 6? 1. That's the maximum offset. And then it goes on to say if the offset is greater than the maximum offset, so that means if whatever variable integer you put in here that you want to add to it, so this is your access level, and this is the offset. The offset is just an integer that you can throw in there. So let's say you throw 7 in there and try to do that. It's going to say, because the offset is greater than the maximum offset, which is 1 in this case. And if we were to use restricted 6. So if the offset is greater than the max offset, return custom. Otherwise, return a static cast, which takes access level and converts it to a number. And it allows you to add level val with offset. And then the same with subtraction. The maximum offset for subtraction, if the offset exceeds distance to minimum, which is none, which is 0, then it's a problem. So that means I'd have to do the calculations. Let's find that out. Let's calculate. So we have let's say we have a read only and we want to subtract 1. So read only is 1. Or no, let's say we want to subtract 2 from read only. Read only is 1. 1 minus 2. We got a -1. That's out of bounds. It won't work. It won't let you do that. And if all of this fails, then it just if there's an invalid sign, like let's say you're a goofus and you put 0 here, you can't put 0 there because of this. If sign is not equal to 1 and not equal to -1, it's got to be 1 or -1 because that's adding and subtracting. That's how I set it up. It's kind of cool. I like it. It works. I know it works. I've tested it, but I'm not testing it today. I just wanted to show you some of the pretty intense stuff that I've built. And then we have some string conversions, so access level to string. And that is another way of printing out none, read only, etc., without printing it out from the count or using standard out. You can use that function instead. I think that's all I'm going to record for today. It's a basic little video. It kind of shows you what I've got going on. I have a lot to organize because callback health status, chain health status, like a lot of stuff needs to be reorganized. But for now, that's all.